space fans, welcome back to Space Store Live. We're here with another Space Store Live roundup with space experts and astronomers Nick Howells and Terry Moseley. How are you guys doing?
Much better than we were 2 weeks ago, I think, with all the fantastic science news coming out of the COVID research. So that's hopefully we'll actually be able to see each other soon, which would be nice. Yeah, very good. How are you, Terry?
I'm doing well, yes. Looking forward to this as usual.
You're looking good. You're looking well. Right, so this is a kind of a bit of a last big one for the year, courtesy of our amazing friends at Space Store. We're going to be doing a bit of a Christmas special in however many weeks or so. We're still sorting out all the details of that, but yeah, this is an interesting one because we're actually watching some other stuff live that's happening right now. There's so much going on. It's ridiculous. If you knew how many different iterations we like go through different story ideas and what have you, there's a lot going on. But to kick us off this week, we've got some sad news in the sad passing of Colonel Chuck Yeager. So Chuck Yeager, if you've ever seen the movie The Right Stuff or read Tom Wolfe's incredible book, which is far, far better than the movie, even the Disney kind of one that's recently been redone that just mainly focuses on the Mercury astronauts and their wives, the movie is actually not bad in terms of its depiction of Yeager. This is the man who obviously was the first human being alive to do in level flight anyway, because there's all sorts of stories from World War II about people doing it in dives. Sustained level flight, breaking the sound barrier in the Bell X-1 in 1947 when he was only 24 years old. And there's some amazing stories associated with this. I mean, the best one obviously is the one that was depicted in The Right Stuff, where Colonel Yeager broke his arm just before the flight and had to basically ask one of his mates to construct him something to drag the cockpit over, because whilst he could fly with his arms in this position with the X-1, and that in itself was no mean feat, he was one of the best test pilots in the world, obviously, but he had to close the hatch, and he couldn't do that with his broken arm. So this is one of those amazing stories that Chuck's almost had the most incredible life. And I was saying earlier on social media, it's almost a throwback to that great quote from Newton, if I've seen further, I've been on the shoulders of giants. And this guy was a giant. He could have easily joined the astronaut program, easily been one of the astronauts, easily qualified as one of the Mercury 7, but he wanted to fly aircraft. That was his thing. And if you've ever been to Washington and the Smithsonian Museum, the Bell X-1 is there, and it's one of those few things, I guess, in the space sector that really brings a lump to the throat, and an emotional lump to the throat. There's a few aircraft, the X-15, I'm a big personal fan of. Obviously, the Apollo capsules is one of those in London, the only one outside the continental United States in the Apollo 10 capsule. But seeing the X-1 up close is something else. So hopefully when all this pandemic horror is over, if any of you out there listening or watching get a chance to go over to the Smithsonian, I know some of you are watching have been to the Smithsonian and been live tweeting and live messaging from there. It's well worth seeing. Yeager was an absolute legend. I don't know, Terry, what you've obviously you've known about this guy for many years.
I remember when the news broke that the sound barrier had been broken. And of course, as you say, he was never actually an astronaut and never wanted to be one. But he also got up higher than anybody else at the time, not quite to the edge of space, but certainly high enough up to see the curvature of the Earth and the blackness of the extreme darkness of the sky above. And I'm sure, as you say, if he had wanted to be an astronaut, he'd have qualified. So sad day, but he'd be remembered.
It's interesting as well. I was showing the team before. So anyone who knows me, I'm a bit of a passionate kind of collector of space memorabilia. And this is part of Colonel Yeager's aircraft, the NS-104. So that was an aircraft developed by Lockheed. And they did some remarkable work in terms of rocket aircraft. And it was the one that famously he crashed in the movie The Right Stuff, if you've seen that. There's bits of it scattered all over the desert. Had some very wonderful friends who literally went out into the middle of the desert and were picking up pieces. You can still see the paint on some of those bits. It's one of those amazing things that, just to be able to touch a piece of history, I guess. But yeah, it's a sad day. But anyway, moving on to touching history. Chang'e 5, or Changi as the popular press seem to call it, but Chang'e 5. This mission just keeps on delivering incredible stuff, doesn't it, Terry? It's brilliant.
Yeah, and the amazing thing is it's all done robotically. In fact, more than just robotically, it's done by artificial intelligence. We're going to be talking a bit more about sort of the second half of the mission, but the first half is the most amazing thing. If you actually watch the video, you can see the spacecraft going down, imaging the surface as it goes, looking at to compare photographs taken from space with where it is, saying, yes, right, I'm over the right place. I'll go down a bit further, goes down a bit further and starting to see detail on the surface, like, okay, I don't like the look of that rock over there, I'm going to move a little bit. Absolutely amazing. And this is being done in real time by the artificial intelligence on board. Then it decides, yes, that's a good place to go down, actually touches down, totally successful. And while the folks back in China are watching, they're not actually controlling this themselves. And as probably most of you know, it landed on the Oceanus Procellarum, or actually a bay off that called the Bay of Dew, which I suppose you can get if you can have an ocean on the moon, you can also have dew, all of course totally imaginary. But it landed in a very interesting area on the moon near a big volcanic mound, in fact a complex about 80, 90 kilometers across called Rumker. Used to be called Mount Rumker, but I think it's now called the Rumker Plateau. A very complex area geologically, and the interesting thing about it is that it's much newer in terms of the age of the moon than the areas where the Apollo and other remote sampling missions landed. So the rocks that were brought back mainly by the Apollo missions were very, very old, near the sort of early stage of the development of the moon. But we didn't really know very much about what happened after that. So this area is thought to be about only 1 billion years old, and astronomers talk about only 1 billion because the universe is 13.8 billion years old and the solar between 4.5, 4.6, maybe nearly up to 4.7 billion years old, depending on how you define when it actually started. So most of the moon is of the order of 4.5 to 5 billion years old. This area only about 1 billion. So that's going to tell us about how the moon evolved much later in its life. And the thing about looking at the moon is that it's basically almost part of the same Earth system. The Earth-Moon is often described as a double planet. When we look at the Earth, everything that we see in the Earth has been modified by erosion, by weathering, by plate tectonics, and so on. But when you look at something on the moon, apart from impacts from meteorites over the many centuries and millennia, it's pretty much as it originally was. It hasn't been modified. So it's very important to get that particular area sampled. The spacecraft did indeed pick up approximately 2 kilograms of lunar material from that area. And again, the next stage is also entirely robotic. The ascent part of the spacecraft took off, went up into lunar orbit and rendezvoused with the orbiter, which was orbiting obviously in the moon above it, docked with it, again robotically, transferred over the samples into the capsule that will come back to Earth. Now, it's not on its way back yet. It is safely in that capsule, which is orbiting the moon, attached to the main orbiter rocket. It has to wait for approximately a week for the alignment of the moon and the area where it's going to land in Mongolia to be exactly aligned. Then it starts the return journey with the return capsule then being released. And because it's coming back from the moon, it is going to be going very much faster than, say, the re-entry of any of the orbiting satellites around the Earth or the spacecraft and so on. It's going to be going so fast that, in fact, it won't enter the atmosphere directly. It will hit the atmosphere and bounce off it slightly, reducing its velocity, and then make a second entry. And then it will come down in the desert in Inner Mongolia. You might think that's a bit strange. It's adding just an extra area of complexity. If they don't get the density of the upper atmosphere exactly right, and allow for that, and just how much it's going to skip off the atmosphere and where it will come back down again, it could land a bit further away than from where they expect. But they're obviously confident enough that they can get that right. So it's been amazingly successful so far. they've only got 2 kilograms, I suppose, compared with the larger amount that the Apollo astronauts got back. But it is from an area that has never been sampled before, and hoping they get it all back on Earth safely and analyze it is going to tell us a lot about the development and the evolution of the moon.
It's fascinating. I mean, the moon, for those of you who don't know, when it initially formed, was considerably closer to the Earth. And we owe our rotation rate to the fact that we have the moon in orbit around us. With no moon, we'd probably be rotating anywhere between 7 to 8 hours being our day, rather than just under 24 hours being our day. So it is really, really interesting to do this compare and contrast between some of the Apollo samples, some of the lunar samples that were brought back with the Russians in the mid-1970s, and these. As Terry said, in terms of the mission complexity, it is quite remarkable. The AI engine, as you said, handling all of the autonomous docking, landing, EDL landing, I mean, descent landing on the moon, as has been proved by the Indians and the Israelis quite recently, is incredibly complex anyway. And there's all sorts of stories that were coming out just today about the potential for the Indian mission being sabotaged by a hack, which is possibly why that one failed. That was literally just kind of relayed to me today. If that's true, who knows? But the Chinese definitely, with the lander and the EDL system, the entry, descent and landing system that are used here, this ability to identify the terrain around it with sub-pixel resolution, very similar to what OSIRIS-REx was doing in terms of the sampling. They were taking masses of images. This is more relying on the autonomy, and even though it's only about a couple of seconds in terms of light travel time from the Earth to the moon, and the ground controllers could probably do quite a lot in terms of command override, this choice of an autonomous engine is, I think, really paving the way forward for what we hopefully will expect in the coming decades. It's also interesting, the Long March rocket launched 4 separate rockets, or 4 separate parts and components of this system. As Terry said, you've got the main launch itself, then obviously you've got the orbiter going around the moon, you've got the descent part of the mission, very similar to Apollo, with the ascent vehicle on top of that. That would then take off, redock with the orbiter, then, as Terry said, it's going around the moon in its orbital lunar orbit until it does what's called a TEI maneuver, trans-Earth injection maneuver, and then coming back and doing this skipping, this aerobrake skipping maneuver on the Earth's upper atmosphere. And this is common on Mars, as a lot of the Mars missions will use aerobraking to decelerate themselves. But you are looking at a re-entry velocity anywhere upwards of around about 24 to 25,000 miles an hour, because you're coming back from the moon. And this is akin again to the Apollo re-entry, the world record being in Apollo 10, which is around about 25,000 miles an hour. So the fastest human beings that have ever been in anything was on Apollo 10. But these are the kind of velocities we're dealing with here. So they do have to kind of decelerate. I wish them all the success in the world. 2 kilograms of material is nothing to be sniffed at. I mean, this is the largest consignment, I would say, since Apollo that's come back. So I just hope that the Chinese are as open and transparent in terms of what they've shown the world with their amazing technology, with the vehicle itself, in terms of the science that comes out of these sample returns. I think that would be a great thing. Which brings us oh, go on.
Sorry, the variable is that the upper atmosphere changes its density according to solar activity. In fact, there's a coronal mass ejection on its way to the Earth at the moment. So they'll have to be fairly up to date on just how much this spacecraft is going to skip whenever it hits the atmosphere. And it's coming in at quite a shallow angle. So, if it goes an extra 100 kilometers further than they expected, it's going to be fun on the retrieval. But they're the experts. I'll leave it up to them.
I think the geopolitical implications of it bouncing somewhere that the Chinese don't want would be interesting.
Yeah,
I mean, at least with our next story, we'll move on to our next story because it kind of ties in quite nicely. This is the Hayabusa 2. So again, this is a sample return mission from the asteroid Ryugu. And Hayabusa 2 successfully touched down on Ryugu some time ago now, collected 100 milligrams of material. Now, just to show you what 100 milligrams looks like, this is 100 milligrams of lunar dust from a lunar meteorite. So we are talking about a very, very, very small amount. We're talking about like vaccine vial, if you're into your COVID stories at the moment, size of material. It's not a lot. but it's a significant enough amount from an asteroid. And I know there's a lot of interest. Professor Alan Fitzsimmons over at Queen's University in Belfast, near where Terry is, he's really excited about this, because these samples, unlike with the Chinese mission, these samples are going to be distributed all around the world. So universities in Glasgow, at the Natural History Museum, University of Manchester, Katie Joy and her team, Sarah Summit, there's all sorts of different people who are going to be working on this all around the world to analyze different aspects of it. And if you think, well, that's a really, really tiny amount, what can you actually do with that? I was very fortunate to be at a lab where they were doing some examinations of some of the actual Apollo mission samples. These were microscopic amounts, but the data that they were able to get out of them in terms of lunar formation, and the interesting research that was being done was looking at the moon's kind of journey around the galaxy, as it were. Because if you think about it, our solar system's orbiting the galaxy once every approximately 250 million years. So to be able to see what differential effects have occurred on the moon, which hasn't got atmospheric protection, as Terry said, doesn't have the plate tectonics and weathering that we've got, I found fascinating. And the research that came out of, like I said, these very, very small samples from one of the Apollo missions, I think there's a lot of science here. This thing landed in Woomera. Now, Woomera is part of Australia. It screeched over Coober Pedy, which is another part of Australia. It was picked up on all sorts of cameras. So, and then the helicopter recovery, this was in the middle of the night. Helicopter recovery went out. They had onboard beacon tracking, so they knew roughly where it landed, but it was still a very nervous time for the scientists involved. And it landed in Woomera. Now, Woomera is the Australian Air Force's, Royal Australian Air Force's test range. And interestingly, it was also the site of the only launch of a British rocket in Black Arrow and the Prospero satellite 50 years ago now. So there's some really interesting tie-ins here. It's going back to JAXA. It's now safely on its way. I think it's actually landed now in Japan at the JAXA Research Lab. This is going to be fascinating as well, just to see, you know, because we're looking at the earliest formation of the solar system. Yes, meteorites. I've got a cabinet full of meteorites behind me. Meteorites are exquisite, but once they've hit the atmosphere and landed on the Earth, they're not as pristine as they could be. This thing is absolutely pristine material, you know, encased, as you can see there, and protected really, really well. Unlike some of the missions that have returned before where, you know, the capsules have sadly smashed open. This is real pristine material, and I think we're going to learn a lot from it. Terry, any thoughts on that?
Yep. It's a particularly interesting type of asteroid. Again, this is your field rather than mine, a C-type carbonaceous chondrite, which is basically prebiotic. Yeah, you've got loads of them there, but very, very interesting in terms of the precursors to life, the chemicals, and the amino acid, that sort of thing, where we're building up towards what may have been developing eventually into life. It actually made 2 touchdowns to collect samples, one actually off the surface, and then it also blasted a little crater to expose the area underneath and took samples from that as well. So again, fascinating, ambitious, and so far, well, evidently 100% successful, and that's got the samples back. But the spacecraft hasn't finished yet. After it dropped off the capsule, it's headed off and it's going to encounter another asteroid in 2031. Only a tiny one, but the interesting thing about it is that it rotates very, very fast. It spins on its axis once every 10 minutes. And that's called 1998 KY26. So it's amazing how they're getting an extra bang for the buck, as they say, or buy one, get one free, whatever analogy you want to use. But again, fantastic mission, 100% successful, and good on them.
It reminds me of a deep impact mission that was run out of the University of Maryland a few years ago, where again they kind of did a tour of comets. And they went, obviously, the Deep Impact mission was such a success. They then went on to 103P Hartley 2, which is this hyperactive mini comet. It was like a 5-year-old on Smarties. Quite amazing mission. Looked a bit like a chicken drumstick, like a Kentucky Fried Chicken drumstick. Other drumsticks are available. The carbonaceous chondrites are fascinating. Now, this is a piece of one called Allende, which landed in 1969 and is reckoned to be the most studied meteorite in history. It's literally, as Terry's saying, it's got some of these primitive organic material. Some of the contents and some of the carbonaceous chondrites literally predate the solar system. They've got what's called pre-solar grains. So the shock impact that's believed to have created our solar system, possibly a supernova, kind of compressing the gas cloud that would have then condensed to form the sun, and then the sun obviously, you know, igniting and kind of kicking out everything into the solar system. Some of that material is still locked in some of these meteorites, and it is just amazing to think that, you know, you could be holding something that, yes, the average meteorite, when you hold it, and it's great with kids, and you say, you know, how old do you think that is? And they'll say, oh, is it as old as the dinosaurs? And you say, well, no, the last dinosaurs were 66 million years ago. This is like 4.5 billion years old. But then some of these meteorites go back 8 billion years in terms of some of the material that's contained within. So fascinating hobby. I know the guys at the Space Store are big into meteorites as well. So it's one of those, I just love them. They're, you know, every time you're touching it, you're touching space. You're touching something that spent 99% of the last 4 point however many billion years orbiting between, you know, potentially Mars and Jupiter or somewhere interesting. So definitely a lot of fun. Moving on now to our next story, because we are racing on tonight. The belly flop. So I've got this on another screen. I'm watching this live now, the Boca Chica feed. So the Boca Chica rocket factory down in Texas has been doing some amazing work. If anyone's watched some of the grain silo takeoffs, as we call them, some of the test articles for the SNs, serial number like 1, 2, 3, 4, 5, etc. They're now up to serial number 8, SN8, and this rocket is a behemoth. This is half the size of a Saturn V. This thing's like 150 meters tall, looks like something from a Tintin cartoon, and potentially, if you're watching this live, within the next few hours, this thing could be taking off and creating history. Terry, go.
Yeah. So far, he's been 100% successful with these. I mean, there have been 1 or 2 failures, but basically, he's progressed and is now at iteration number 8. He's also just, you know, we've often said mixed things about Elon Musk, but to give him credit where it's due, he's just launched his 100th Falcon 9 and recovered it, and he set the sort of the pace for recovery of rockets. This one's due to go up to, what is it, 49,000
oh
feet.
yeah, 12.5
like
kilometers.
Yeah, not fully up into space, but high enough up to test all the engines, 6 of the big Raptor engines. And this is all basically part of his drive to get to the moon and eventually to Mars. And what really captured my interest was that a speech that he gave, or a discussion live on TV with a German firm about his plans for Mars. And he was saying, he's quoted anyway, as saying that the first crewed mission to Mars could go as early as 2024, but almost certainly by 2026. And I was doing a double take. Now, a robotic mission to Mars in 2024, no problem. A crewed mission is a whole new ball game. So why, if he doesn't get 2024, why would it have to be 2026? That's because the windows to launch to Mars, whenever it comes closest to Earth, occur every 2 years and 2 months, every 26 months, basically. Now, you've probably heard us talk in the past about the Super Heavy rocket, which is the big beast. It has 30 of these Raptor engines, and it will launch the Starship, which itself is 165 feet or 50 meters tall. The one that goes to Mars, it itself is powered by 6 of those Raptor engines. Now, this is where the fun begins. You're talking about an 8-month mission to get to Mars with a crew on board. He hasn't specified how many, but I'd imagine a minimum of 3 or 4. Getting them to Mars isn't all that difficult. He has the technology, he has the power there, he can do it. What happens when they get there? He needs on board that spaceship all the supplies for the 8-month journey to get there. He needs everything to keep them alive on the surface of the planet for at least 8 months, because they have to stay there that long before they get another opportunity to come back. And getting all that there before either 2024 or even by 2026 is really, really ambitious. He needs, first of all, the food, the oxygen, the water, the CO2 scrubbers, and all the rest of it for the 8-month mission to get there. When they stay on Mars for 8 months, they need, again, oxygen, food, water, shelter from the cold, because it gets exceedingly cold on Mars on the nighttime side, because there's very little atmosphere to hold it in the heat. The radiation from both the sun and from cosmic rays, medical supplies for anybody that might feel ill, After 8 months, they need to come back again. So he needs to have set up on the surface of Mars a robotic factory to create enough fuel to get the rocket to take off and come back again. Okay, the gravity on Mars is a lot less than it is on Earth. It's a bit less than half in terms of the escape velocity. So it doesn't need quite so much fuel to take off from Mars as it does from Earth. It still needs quite a bit. And again, he needs then the oxygen, the water, and the food to get the crew back on an 8-month return journey, and enough fuel to decelerate and land. And much though I admire Musk's progress so far in this, I honestly think that is not possible. Certainly not possible by 2024, and probably not possible by 2026. I think he's being foolishly ambitious. What do you think, Nick?
I don't know, the single stage concept, obviously this is all again harping back to the early days of Apollo when they were looking at how they were going to get to the moon. Now he's looking at both a single stage to orbit and a single stage deceleration from orbit. To my mind, the only way he would actually achieve this is with a multiple Starship mission. So if he was to launch potentially 2 Starships in parallel, one as a supply vehicle, all of the additional oxygen, habitats, etc., that Terry's just mentioning, to land almost in parallel or just ahead of the initial landing mission, then at least he gets around that problem. If he was to put a third one up, and don't forget the cadence that he's talking about, the kind of replayability, as it were, of this rocket. If this SN8 launches today, he's looking at launching SN9 within 2 weeks. They've already got it on the production line. So in terms of the rocket turnover, as Terry said, you only have to look at what he's doing with the Falcons. You know, those things have got an incredible turnover time. He's launching more rockets than anybody at the moment, and obviously putting up lots of Starlinks and all the things that are annoying all the astronomers. But if he was to put up, say, 3 or potentially 4 Starships, where you left one in orbit as an orbital recovery vehicle, where you've essentially got a lifeboat in orbit just in case something does go wrong. Then you've got the ascent-descent stage, obviously on the main rocket, which they go down in. If you put a third one on the surface that gave you the supply, you know, et cetera, that's needed, and have another one ready to go, almost to say, okay, well, if this one fails for whatever reason, we've got another backup, and then potentially put another one in low Earth orbit as, again, a recovery system or another form of lifeboat that could possibly go out to a meeting point, as it were. Incredibly difficult, complex orbital dynamics involved with that, but never say never with Musk, because you just don't. Then potentially 2026, I would say not so much for a landed mission. I would say if he's saying sending humans to Mars, he doesn't have to land them. He's saying
the implication is that they're going to be landed. That's what he's always been talking about.
I think an Apollo 8 style mission by 2026 is potentially viable. As you said, this home and transfer, this kind of 26-month window, as it were, between the Earth and Mars. Yeah, it does limit you. Obviously, he's got the most powerful rocket, or is very soon going to have the most powerful rocket that's ever launched. So in terms of, you know, transfer time, etc., yeah, it's going to take that many months. But again, you just don't know what he's got up his sleeve in terms of, you know, performing additional boost burns. You know, he's not. I don't think the fuel issues that plague so many of the other smaller rockets, you know, especially with payloads, etc., are going to be as much of a concern for him, especially if he puts 2 up at the same time. If he can get a Starship into Earth orbit and then refuel it, he could do a trans-Mars burn that would beat all records. So who knows what he's got up his sleeve? It's going to be really interesting to watch. I'm really excited about this. It's kind of tempering. It really is. You've got to balance this between the kind of fanatical Musk can do no wrong kind of thing with, you know, things do go wrong in space. And, you know, he's just been granted $900 million by the FCC in America for Starlink, for broadband internet over the United States. And everyone's going, oh, isn't that fantastic? Well, it's not. It's polluting the sky. We know that. From the beta tests, most of the people who are using it are playing Call of Duty on their Xboxes via the internet. So it's hardly delivering the altruistic broadband internet for all that everyone was going on about. And there's so many other ways of doing it. If you take into account what OneWeb are planning, you know, the British government, with potentially what the Chinese are going to do, with what the Russians are going to do, with their big constellations in space, you know, Musk could be lucky if he does get to launch, because it can be so crowded up there that we don't even have a chance to launch. So it could be an unholy mess up there. Anyway, it's going to be interesting to watch. I can't wait to see this thing take off and land again. 12.5 kilometers. It's going to be spectacular, especially the size of this thing. It's going to be something else. But yeah,
I would agree that if he adopted the techniques that you're talking about, or rendezvous in Mars orbit and in Earth orbit, he hasn't practiced any of that yet.
No.
As you say, he may have things up his sleeve, but that has not been demonstrated. The crew transfer in space from one spaceship to another, apart from docking with the ISS, which is totally different technology. That's the Falcon 9. It's not the big Mars spaceship. I wish him luck, but I just think, I suppose the dictum is, he who aims the sky hits higher far than he who aims at the trees. So
yeah, and
aim for it.
You know, when Kennedy announced we're going to go to the moon, you know, we all remember what James Webb said in 1961 was, does anyone want my job? Because what he was proposing was impossible. Or as everyone, you know, thought, it's 9 years when they didn't have the tracking, they didn't have the computers, they didn't have any of the technology. At least in the modern era, the technology issue is not.
Technology is there.
The technology is there. Obviously, human constraints in terms of bone mass degradation, radiation poisoning, all these types of things have still got to be solved properly. Obviously, we've come a long way, and there's all sorts of talk about hibernation now, going back to the science fiction days, what we saw in the movies like Alien, you know, the early Alien movies with the kind of cryo hibernation systems. That kind of technology is still being kind of looked at and pursued as a potential for these deep space missions. It's going to be interesting. You can't bet against him. This is the thing. Everyone who does gets burnt. So you just can't.
I bet £100 that he won't, but nobody's taken me up on it yet.
Yeah, I'd say 2026 for an uncrewed mission, yes. 2028, I think, realistically, if he's going to send even just an Apollo 8 style, you know, trans-Mars kind of circular orbital mission, let people orbit Mars for a little while and then come back. Again, it depends on these burn times. As Terry said, the orbital insertion and the orbital transfers are very specific in this 26-month period. But if he can get there a lot faster and he can get back a lot faster, then potentially he could shorten this issue by some margin. It depends on the fuel. And if he was to put something in orbit around Mars and something in orbit around Earth to act as refueling stations, he's got around that problem. Now, Terry was saying about he can't do this docking. Well, he's doing, I know it's Falcon 9, but the autonomous engine on the Falcon 9 and the Crew Dragon is, again, quite remarkable. He's nailing those on a completely autonomous basis. And that's, you know, with crew in and without crew in. Right now, the ISS has got 2 Dragon modules attached.
Yeah, 2 attached at once.
So I wouldn't say he's incapable of doing, you know, crew transfer in the 60s when they were practicing from Apollo. You know, they didn't have this. They had the computing power of a pocket watch. It was, you know, it was non-existent. You know, 4 kilobytes was considered a large amount of memory. You know, 4 megahertz processor was tearing along. So, yeah, it's never say never with Musk.
I'd be delighted to be wrong.
I would be delighted if you to be wrong as well. It's one of those things, Terry. You're very fortunate in that you will have seen Apollo. I was born the day Apollo 12 was on the moon. I got to see this in my lifetime. I've got to see something spectacular in my lifetime that isn't a robotic mission. So, yeah, fingers crossed.
Okie doke.
Anyway, moving on. Bit of a sad one this now. We reported on this in the last show. The Arecibo radio telescope, up until recently the largest radio telescope on Earth, until the Chinese FAST telescope came online a few years ago, the 500-meter FAST telescope. This at 305 meters is no slouch. Puerto Rico has had an awful time of it over the past few years. It's been battered by hurricanes. That didn't touch the telescope. Everything was okay. It's had, you know, the pandemic to deal with. You know, they're getting through that. The Puerto Rican people seem to be absolutely devastated by this loss. It's like losing a family friend or a relative, they've said. And if any of you have seen the videos of the collapse of this on like space.com, etc., it really is heart-wrenching, isn't it, Terry?
Yeah, I know. I heard about it happening before I actually saw the video. When I saw the video, I thought, oh, no. You know, it was just so tragic. One of the newspaper headlines was the James Bond telescope collapses. I thought, I didn't know James Bond had a telescope. And that's the media for you. It featured in one of the James Bond films.
Yeah, GoldenEye. Yeah,
Finger.
GoldenEye.
Yeah. Anyway, but it was an iconic telescope, the biggest in the world for around about 60 years until the latest Chinese one. And it did just about everything. It was ambitious in its time because it's a non-steerable dish. It literally is just sitting in this big natural bowl in the middle of the forest in Puerto Rico. And just sort of from that point of view, you think, well, it can only point straight up. But they actually were able to point it around the sky quite a bit by moving the secondary, which you can see more or less collapsed in the middle of that dish there. By moving it, they could effectively point it to different parts of the sky. And it was used for everything, for search for extraterrestrial intelligence, for tracking near-Earth objects, for very, very accurate radar measurements to the Moon and Mars and Venus. Radar mapping of objects that fly relatively close to us, like, for example, the famous Oumuamua, the object that came from somewhere outside our solar system. There's all sorts of debates about what it was, but a very odd shaped, possibly an asteroid type.
Aliens, Terry.
Yeah, aliens, of course. Distant radio galaxies and quasars. It contributed more than you can probably contemplate to our knowledge of the distant universe, simply because it was so big and so powerful. It was getting near the end of its life. There were funding issues and so on. Whenever there was damage caused by the hurricane and minor earthquakes and so on, people were reluctant to come up with money to keep it going. Eventually the NSF took it over. But now with that collapse, it's just beyond repair. There's some talk about possibly building a complete new telescope from scratch on that site, but again, that'll take a lot of money. I'm not sure that's going to happen, but it is tragic to see it like that. And if you haven't seen the video, watch it. It's just amazing to watch what actually happened.
It's gut-wrenching. The one positive, I guess, you can take from this is, as you said, it's been doing remarkable science. That's it in its former glory. Beautiful, beautiful instrument. The science platform there alone, I mean, this is a multi-ton science platform that was held by these, cables that have essentially had rotted. And I think it's a real tragedy. The NSF, National Science Foundation, taking this over and not kind of funding it sufficiently to enable the repairs that were clearly needed over the past few decades. You don't have to watch the movie Contact, the Carl Sagan book that got turned into a Jodie Foster movie about 20 years ago. And at the time, there was all sorts of talk about the telescope not being operational for much longer and funding being cut, and that was highlighted in the movie. This is the kind of thing that should never be let happen. If we can find, or if the US government can find $667 billion a year to fund its Department of Defense, i.e. killing people, why on earth can't some additional funding be put into something so remarkable? And now, China are really leaping ahead here. It's almost going back to the Apollo days again with the whole race between the Soviet Union and the Americans. You look at what China are doing with the moon. You look at what China are doing in terms of their orbital plans with their space station. You look at what China have now got in terms of radio telescope with the FAST telescope. They've got the most powerful radio telescope on Earth. The one and only thing I take some solace from this on is a few years ago, well, some decades ago now, they broadcast a signal out to M13, the globular cluster, this kind of hello, we're Earth signal. And that's going to be traveling through space long after this telescope's gone, long after we're all gone. And potentially, who knows, one day somebody watching EastEnders on a planet orbiting a star near M13 might pick it up and go, oh, look at this, isn't this interesting? Who knows? It's really funny at the moment. We're laughing about aliens. There was a story that came out today about where I think it was an Israeli science minister had said that we're part of a galactic federation and that it's all a big cover-up, and all the conspiracy theorists are going nuts over this. It's bunkum. But hey-ho, we like to cover the real science and the real facts on this radio show here and our broadcast here. So, it's a really long, sad goodbye to the Arecibo telescope.
The other thing about it is, while the Chinese telescope is bigger, it's much further north. And so it can't cover a whole area of the southern sky that the Arecibo telescope is able to. So whether they might even build one somewhere in the southern hemisphere, Puerto Rico was quite close to the equator, but it was north of it. But somewhere in, say, South America, between the two of them would cover the whole sky. But
I think the latitude's probably quite important. If you do retain something in the mid latitudes and the northerly latitudes, the SKA telescope, the square kilometre array, pretty much is going to cover a lot of the southern sky. I mean, that's being built in the Karoo desert regions in South Africa and the Murchison region in Australia, the low frequency, mid frequency, high frequency arrays. That is going to be the biggest radio telescope ever built, but it's not a single dish. It's a multitude using a technique called interferometry to combine and give you basically a telescope the size of the Earth, in effect, or the size of the distance between Australia and South Africa anyway. So it's a massive baseline telescope. And the resolution on that is going to exceed the Hubble by a factor of 50. So having a radio telescope, and radio, obviously, radio wavelengths are like that and optical wavelengths are like that. So to have a radio telescope that's able to give you image resolution, image in the kind of non-traditional sense, but a resolution that's higher than that of the Hubble Space Telescope is going to be remarkable in itself. If, again, that ever goes fully online, because that's still going through all sorts of funding issues as well. So, again, watch this space, as it were. It's such a great time to be into astronomy and space science.
The thing about the SKA, it won't have radar capabilities. You're not the same radar capabilities that this one has.
Yeah.
Anyway,
but
what's happening?
It can point anywhere. Which brings us nicely on to what's happening in the sky. This ability to point anywhere, the SKA, if you go out to a dark sky location, and this is one of the things that I guess Terry and I are both very fortunate to either live in or near to accessible dark sky regions. Just go out over the winter months now when it's really, really dark and it gets dark nice and early. Just get out, get a flask of coffee or tea or your favorite drink, get a deck chair and just look up, because it is absolutely spectacular. And you look at how many stars you can see in the average urban, like city location, it's in the dozens. You go out to a dark sky location and the view that you can see on your screen there is literally what you're going to be seeing. So if nothing else, you know, there's so much to see in the sky, as Terry's going to talk about in a minute, but just get out, especially at Christmas. You know, we've all had such a horrendous year with being locked down. And, you know, if you've got kids and they've been stuck inside, take them out, wrap them up warm, take them out and let them look at the sky, because it will spark an interest. I will guarantee you it will spark an interest that could potentially last a lifetime and could give us the next kind of batch of scientists that we really need. And you look at what science has done for the human race in the last few weeks. It's science that's going to pull us out of COVID. It's science that's going to help us get back to normal. So these are the kids now are the scientists of the future. So before Terry tells you what to look at, that's my message. Just get your kids and just go out and look at the wonders of what's up in the sky.
Yeah. This time of year, for a start, you have very, very long nights. Unfortunately, they're usually pretty cold whenever it's clear, but modern clothing will compensate for that. And at this time of the year, you see basically the glories of the brightest stars in the sky. Depending just where you are in terms of latitude in the UK, you can see most of the brightest stars in the sky throughout the night from dawn to dusk. In particular, you can see Sirius, the brightest of all the stars that we can see. We can see the glories of Orion, the Betelgeuse, the bright red supergiant in the top left corner as we look at it. Bright blue-white supergiant Rigel in the bottom right-hand corner. You've got the Pleiades of the Seven Sisters. You've got a whole lot of other bright stars that are visible, like Aldebaran and Procyon and Capella almost overhead. Absolutely outstanding views of the sky. Just by going out and letting your eyes adapt to the dark. Get away from all the artificial lights and wait at least 10 minutes, preferably more, and you'll start to see stars that you just didn't believe were there. But in particular, there are two amazing events coming up in this month. First of all, this is the most magnificent meteor shower of the year, the Geminids. They're called that because the meteors appear to come from the constellation Gemini. That's active at the moment, actually, but it builds up to a peak, and that peak is on the night on the 12th, 13th of December. And you see quite a few meteors, if it's clear, obviously, that night as well as the night before and after. And if you're in a really dark sky, away from all light pollution, and you allow your eyes to adapt totally to the dark, you could be seeing on average 2 meteors per minute. Not regularly like that, but on average you can see up to about 2 meters per minute. And that's a free sky show. And you're looking at little particles, basically a comet that has been left behind in the comet's orbit, and the Earth's orbit intersects the trail of debris left behind by the comet, and these particles rush into our upper atmosphere at speeds of 710 miles per second and just burn away in the flash of light that you see. And something that's bright enough to be really noticeable is only about the size of a pea, sometimes even only the size of a grape pip. But what you're seeing is not the object itself. You're seeing it destroying itself in a flash of light as it ionizes the atmosphere in the upper atmosphere. But the most remarkable thing of all is what we call the grand conjunction on the 21st of December, which is just by coincidence the winter solstice. And this is when the two largest planets in the solar system, Jupiter and Saturn, appear very, very close together in the sky. They pass each other roughly every 19 and a bit years because of the relative orbital speeds of the two planets. But this time they're coming very close together, not actually in space, but just as we see them. It's just a line of sight effect. And on the evening of the 21st of December, you need to go out just as soon as the sky is starting to get dark and look for them. They're only visible in the twilight, low in the southwest. They'll be so close together that for some people, they might even appear as just one object. But if you look very closely, you'll be able to see two. Jupiter's actually a good bit brighter than Saturn because it's bigger and nearer to us. But the separation between them at just after sunset on the evening of the 21st of December will be 6 arc minutes. That's a fifth of the diameter of the moon. And that's the closest they'll be together for a long, long time. It won't be until 2080 until they appear that close together again. And going back in history, the last time that they were that close was 1623. Would not have been visible from Europe or America then. It would have been visible from the equator. Going back to 1226, year 1226 was the last time that you could have seen them from here in the UK as close together as that. You see them with the naked eye, you get an even better view with binoculars. And if you have a telescope, take it out and look, and you'll be able to see in the eyepiece simultaneously the two largest planets in the solar system and at least half a dozen moons. The 4 bright ones of Jupiter, the so-called Galilean moons, and probably the 2 brightest ones of Saturn, if it's a reasonable telescope. That's Titan and Rhea. And if it's a really good telescope, you can maybe see another couple of Saturnian ones. So it would be possible in the right conditions with a good telescope to see 10 solar system objects simultaneously in the eyepiece. And I've never seen that. I'm hoping to see it this time. And if you don't see it this time, you'll not get another chance to 2080. As I say, they'll be at their closest on the 21st of December, but they'll still be remarkably close even the evening before and the evening after. So if it's cloudy that evening, do make a point of looking 20th and 21st and 22nd of December. It'll be an absolutely amazing sight.
Yeah, really well. And if it's cloudy for the whole week, which isn't uncommon in Northern Europe, there's loads and loads of online telescopes who are going to be covering this, and people like SLU, etc. They're going to be doing probably an amazing broadcast of this. I can't wait to see it myself with my own eyes. I'm going to take the kids out and hopefully see, show them something. As you said, it's a spectacular show. And if you've never seen Saturn before through a telescope, if you want to give your kids an early Christmas present, get them a telescope. Get them a half decent telescope. Don't get some rubbish from eBay or whatever. Get them a half decent telescope, because seeing Saturn through a telescope is again one of those moments that most people just go, wow. Yeah. It's one of the few objects in the sky, apart from the moon and Jupiter and Mars on a half decent sized telescope, where it literally matches what your mind is perceiving, what your mind imagines. There's so many times you see kids get really disappointed when they look at faint fuzzies in the sky or whatever. And astronomers are used to this, but for kids, it's all about the wow factor. And Saturn and Jupiter together is wow factor like nothing before. So, and nearly 1,000 years since the last time we've seen it. So, it's definitely one to look out for.
It's just beautiful. Quite apart from being fascinating, just the sheer symmetry of Saturn and its rings is a beautiful sight.
Yeah, absolutely. So again, massive thanks to our friends at the Space Store. They do a great job, all voluntary. Everything we do for this is voluntary. They do a great job in terms of hosting us, keeping an eye on what's happening in chat feeds and YouTube channels, presenting, etc. And also, they're a store as well, and they're battling the same as all of the other high streets are with the whole issue with the pandemic and lockdown. So give their website a look. If you're thinking of a nice Christmas present, they do some great outreach, and everything that you get from them really goes to help this amazing outreach that they're doing and the fantastic STEM that they do. So go on their website. There could be jackets, there could be meteorites, all sorts of different things. If there's something you think, oh, my kids would love that for Christmas, have a look on the Space Store website. And it's not like I'm not doing this as a commercial thing. They do such great STEM, and they're a great team of people. So massive thank you to them as ever.
Here, I second that.
Thank you so much, Nick and Terry. Thanks, Nick, for that. Yeah, if you're looking for Christmas presents, do head over to the Space Store website. We do have some amazing stuff. But Nick and Terry, once again, thank you so much for another incredible roundup. I hope everyone who's tuned in today has enjoyed it. I know I thoroughly have. So please hit that thumbs up button, because we need to get more people down here watching this live. We do get lots of people watching it on YouTube after we post it, but it'll be even better if we can get more people watching it live. So give it a thumbs up so it gets seen by more people.
We're clashing with Man United tonight, so
we are. But thanks for tuning in. Next Tuesday we're going to be back for a Christmas special at 7:30 p.m. So tune in then for a Christmas special roundup, and we'll see you there.
Santa hats are not optional.
Thanks, guys. Bye, everybody.
Right, take care, guys.
Cheers, Terry. Bye.